my name is Chirag Dhal and I welcome you all in this video on the behalf of PyNet Labs. In this video, we are going to get an introduction towards local area networks. So let's quickly get started and let's see what do we have to cover in this video. So we'll be having introduction to LANs. So let's see what exactly LANs are. LAN, first of all, stands for local area network, and it is basically a group of devices connected together within the same building. We can say that is the easiest explanation or the definition of local area networks. Now, we all know that networks are basically connecting devices together. When this connection is within the same building, or we can say within a small geographical location or small geographical area, then that is usually considered as local area network. For the closest example, we can consider our home networks, where we have a small router / Wi-Fi, which is basically connecting multiple devices to the internet, like connecting some smartphones, maybe some laptops, maybe some PCs. So that can be considered as LAN. Then after that, when we talk about the components of LAN, it includes network cards, which is network interface cards. These are there on your devices, and we can say these are the cards where you insert the Ethernet cables. Then we have the network cables, the important part of any network. These cables are like copper cable or fiber cable, which are used to connect devices together. Then we have network hubs or network switches. Hubs and switches basically do the role of connecting multiple devices together. So we will have some introduction to them later in this video itself. Then routers and access points. Now routers are there for multiple functions. They can be used for many things, but the most, I would say, common and the important function done by the router would be making one network communicate with the other. Then if I talk specifically about access points are there for transmitting the wireless signals. Then after that, if we start talking about the features of switches, it can be said that it is a device which can connect multiple devices together using Ethernet cable. So if I just try explaining you here on the screen with some small diagram representation, let's say this is your switch. It will have some Ethernet ports, and this is your PC, another PC like this, and another PC like this. So using Ethernet cables, you can connect the cable with switch and the PCA, then again like this. And after this point, if these three are in the same network, if their network is same, then we can simply say that they'll be able to communicate with each other. So that's how a switch can be used for connecting multiple devices. Then it says switch is an intelligent device, as it can learn the physical address or the MAC address of devices that are connected to it. So when we connect devices with a switch, it basically learns about the MAC addresses of the connected devices, so that in case, let's say A transmits some packet which is supposed to be delivered to C. So A will send it to switch will look for the destination MAC address into the packet, and then depending upon that, the switch will forward the packet on this port, as it will see that, okay, I have this user connected on port number 3, so I should give it to that port. Then we can say it stores the MAC addresses in its MAC table. When a data packet is sent to a switch, it is only intended to port, which is the destination port. So depending upon the destination, it only sends it to that particular port. Then we have some functions of switches, starting from the very first thing, which says it first broadcasts the message in the network and then perform unicasting. Then it is an intelligent device because it has own memory. Implementation of security is possible when you have switches inside your network, and it works on full duplex mode. So when a switch is connected inside your network, it not only allows you to connect multiple devices, but it also provides you features like enabling security with multiple features. Then full duplex means that devices connected to switch can communicate at the same point of time. It is not mandatory that if one of the devices is making communication with the switch, then other has to wait. That is half duplex communication. But when we talk about full duplex, at the same time, multiple devices can communicate with each other. Then when we talk about these switches, we have some different types of switches. These are like managed switches and unmanaged switches. Managed one allow you like some additional features, we can say, and unmanaged are some simple sort of switches. Now the configuration is there on the managed one, like you can configure things, but on an unmanaged switch, they are definitely easy to use, but at the same time there is a fixed set of configurations which is already there and you cannot manipulate them. So we can say some of the features of managed would be you can configure things, we can say configurations can be done, and in unmanaged we cannot do any configuration, so I'll just write no configuration here. Then the performance also differ on both of the categories. The managed one can perform better, they perform better, and in the case of unmanaged one we can assume a average performance from them, so we can simply say average performance here. Then if we talk about security related features, there are more security features in the managed one. If we talk about like you can put configurations, you get freedom of enabling things on that switch, but in the unmanaged one there is no such freedom, or you can say there are no such security features. So I'll just write security features here and we can say no security features here. Like there are some very basic ones, like maybe covering the port so that no unethical user can connect to it. So some basic ones are definitely there, but we cannot assume some advanced security feature inside a unmanaged switch. So I'll just say no security feature. Then the last one would be on the basis of cost. They are expensive, they are a bit cheap if we compare them both. So I'll just write expensive here, and these are cheap, because they differ on the basis of many things, and this makes it obvious that the managed one are going to be a bit expensive, and the unmanaged one, which cannot be managed, are going to be a bit cheap. So all these things make the difference. Then if we talk about the next thing, if we talk about the working of switch, so we can understand it in this way. Firstly, it broadcasts the message to all known MAC addresses of the connected nodes and then performing unicasting. MAC address of all connected nodes are stored here in the switch. Now this is the switch, there are multiple PCs connected to it. So whenever there will be like a fresh switch placed, it is going to start maintaining a MAC address table. So it will have some entries like this. It will say, let's say ports are going to be there, then there is going to be MAC address like this. Now we should know that a switch only trusts the source MAC address. It is not going to trust the destination MAC address. So it trusts only the source MAC address. Let's say this is your user A and this is your user B, C, D, E, F, G, and H. In this case, basically we will assume that they are connected to port number 1, 2, 3, 4, 5, 6, 7 like that. Let's assume that the MAC address of this user A is AA, then the user B is B, C, and like that, so on and so forth. Now when this user will send the packet to switch, that packet will contain 4 things. It will definitely contain many things, but it will have the source MAC as AA. Let's say that packet is supposed to be delivered to G in this case, which has the MAC address of G. So the destination MAC address is going to be G, right? Then it will have some source IP, then we'll have some destination IP. Now when this packet reaches the switch, as we have already discussed that it only trusts the source MAC, so switch will look into the packet, will see, okay, I have a source MAC address of AA, and this packet is received from port number 1. So I should make an entry here inside the MAC address table. I will say that, okay, on port number 1, I have a user connected whose MAC address is AA. Then when the when the switch will find that, okay, the destination MAC address is G. Let me see if I have any entry of G inside my MAC address table. When it doesn't find any entry, it will broadcast it to everyone. So everyone will receive that packet, and we can say that packet will ask everyone that, hey there, is there anyone having MAC address as G? And to which this user G this user is going to reply that, hey switch, I am the one who has the MAC address double G. Now that reply will have the source MAC address as double G. Try to understand this. When a reply will be sent from this PC to the switch, then the source MAC address of that packet will be double G, right? And then again, we know that switch trusts the source MAC address. So it is going to make the entry that, okay, on port number 7, we have a user double G. And if now anyone will send any packet which is supposed to be delivered to user G, then it is simply going to send it to port number 7, as it has already made the entry inside the MAC address table of the switch. So that's how a switch works. Now switch, and we had an introduction to the local area network, and switch are the very important part of it. So we have covered how it works, what are some features, what are some different categories of switches. Now there are many things to explore about these switches and local area networks, which you can read about. So we might be covering in the further videos about them. So till then, I would say take care of yourself, keep studying, and I hope you guys enjoyed the video. Thank you so much for your time.